Good morning, everyone. Today's class is about something nice. We're going to solve problems from Irodov. Just because I thought that you can solve these problems, they're kind of easy. So you should go and try it. Irodov is easily available. You might have Irodov already. If you don't have it, go and get a PDF. In Irodov, section 1.5, dynamics of a solid body is about motion. Okay. So in today's class, we are going to solve a few of those questions. And trust me, we will solve all of them. Let's begin, right? Okay. Question 234. We'll start with question 234. So in your book, if you have this, it will be 1.5, question number 1. Okay. So go see it. Question 234. A thin uniform rod AB of mass m 1 kg moves translationally with an acceleration of 2 meter per second square because of two forces. So the question is a little bit like this. There is a rod, okay, and there are two forces on the rod, F1 and F2. By the way, when you're trying these questions, please try the question on your own before you look at my video. You can solve all of these and all the remaining questions from Irodov as well. Okay, so this is B, that is A. A thin uniform rod AB of mass 1 kg, the mass is given as 1 kg, we'll be using symbols. You can substitute at the end of it. Moves translationally with an acceleration W is equal to 2 meter per second square. Irodov doesn't use A for acceleration, it uses W. There are two anti-parallel forces. Anti-parallel means opposite. Okay, so there are two anti-parallel forces, F1 and F2. Anti-parallel is opposite. The distance between these forces is A, and A is given to you as 20 centimeters. It is also known that the value of F2 is 5 newtons. So a lot of information is given. It's asking you to find out the length of the rod. It's asking you to find out the length of the rod. So what is it asking us to find out? It wants us to find out what is the value of L, what is the length of it. Okay, so how do you solve this question? First of all, the rod is translating. Our rod is translating. That means that our rod is not rotating. Translating, not rotating. Because if it was rotating, then it would say that the rod is translating as well as rotating. But the question clearly says that the rod is translating. It is not rotating. So because something is not rotating, there are two possibilities. First of all, there is no rotational kind of a force on it. There is no rotational force as it is. Forces can cause a rotational effect called as torque. So what I mean is there is no torque on the rod, first of all. Or the second thing is there is a torque, but the net torque is equal to zero. So maybe that is the case over here. So that is the first idea we can get. Maybe the net torque is equal to zero. The net torque is zero. Okay, so maybe that's the case. The net torque is zero. So before we find all of that, to find out torques, we require force. So there are forces F1 and F2. We know the value of F2, but we do not know the value of F1. So F2 is known to us, but the value of F1 is not known. So we should write an equation where F1 and F2 are both involved and we can find out their values. It is translating at the rate of 2 meter per second square. So let us say it is moving towards the right. Okay, it's moving towards the right with this acceleration. So we can write plus F2. It could also move towards the left, by the way. So let's figure out, let's explore and find out. So plus F2 minus F1 is equal to mass into acceleration, m into W. We know the value of F2. So F1 is basically equal to F2 minus MW. F2 minus MW is equal to F1. Now the rod is not rotating. This rod is not at all rotating. So when something is not rotating, you might remember that it is in rotational equilibrium. Okay? It is in rotational equilibrium. And because something is in rotational equilibrium, we can choose any axis we want. And then we can write the sum total of all the torques is equal to zero. ठीक है, याद है रोटेशनल इक्विलिब्रियम में हम लोगों ने पढ़ा है रोटेशनल इक्विलिब्रियम we can choose any axis you want and the total torque is equal to zero. So what I'm going to do is because I want to find out the value of F1 as well, so I'll choose that this is the axis of rotation. Okay. You can, by the way, also choose the center of mass of the rod as an axis of rotation. That is also going to work. So if you want, instead of choosing B as the axis of rotation, you can also choose the center of mass of the rod, which is the midpoint of the rod as the axis of rotation. This is also okay. So okay, let's choose this as the axis of rotation, the midpoint. What are the torques acting on it? There are two torques acting on this thing. One is because of F2 and the other one is because of F1, and both of those torques, they balance out. So you can say that in this case, plus F2. So I'm taking the rightward direction as positive. Plus, what is the distance? The half of the rod is L by 2. So you have to remove A from that. So that is L by 2 minus A. We want to find out L, by the way. So L by 2 minus A into F2. And F1 is going the other way. So minus. And what is the distance from the axis to F1? That total distance is half of the rod. So that's L by 2. So L by, sorry, I got disconnected. So we'll have to do the entire thing once again. The problem basically is that there is a rod, okay, and this is the value of this is F1, that is F2. You can just rewind in the video and go back to that point. I'll start off from where I left there. So I assume that this length is equal to L, and then we also said that F1 is equal to F2 minus MW. The value of F2, MW, everything is given. We want to find out the value of L. So this equation we already did. And I was writing out the torque equations about this point. So this direction was positive and the opposite direction was negative. So I wrote plus L by 2 minus A, that is the distance from the axis to this point, L by 2 minus A, into F2, minus what is the distance from the axis to F1, that is just L by 2 into F1 is equal to 0. Okay, so we took the center of mass as the axis. So you can write L by 2 minus A into F2, we know the value of F2 is equal to L by 2 times F1. So we do not know F1, we'll put the value that is that we derived, which is F2 minus MW. Now let's write this out. L by 2 minus in multiplied by F2 minus A into F2 is equal to L by 2 F2 minus L by 2 MW. Just writing everything out. So it looks like these terms can cancel. So L by 2 into MW is equal to A times F2, is equal to A times F2. So what is A? A is the distance between F1 and F2. We wanted to find out L. So L is equal to 2 times A into F2 divided by MW. L is equal to 2AF2 divided by M into W. Now the values of A, F2, M and W, all of these values, they're given to us. So at this point, what you can do is you can substitute these values and you can find out the answer. I always suggest that you solve using symbols, do not actually solve using values. So now you can put the value of A is equal to 20 centimeter, which is 0.2 meters. The value of F2 is equal to 5 newtons, that's given to us. What is the mass of the rod? That's 1 kg, that's also given to us. And what's the acceleration? That's 2. So basically it looks like everything is going to cancel out to give us a value of 1 meter. So the length of the rod is 1 meter. Okay, it's kind of easy. It's not that hard. I taught you how to write down these force equations. Okay. What is the next concept that we utilized over here? That the system was in rotational equilibrium. So when something is in rotational equilibrium, the net torque is equal to 0. Summation T is equal to 0. You might have seen that instead of taking the end point of this rod as an axis, I took the midpoint of this rod as an axis. That is to keep the calculation easy. Normally, whenever something is moving, try to stick to the center of mass as the axis, or actually always try to stick to the center of mass as the axis. Okay, that will keep your equations and everything else a lot simpler and almost certainly correct. Why did we write down about torques? Basically because once again, the system is in rotational equilibrium and we want to talk about force and we also want to talk about distance. So whenever you want to talk about force and distance, I've told this thing before as well, you should talk about either work and energy or you should talk about torque. So in that sense, we talked about torque because we wanted to find out a distance. Okay? So that is our first problem. Question number 234. Next, question number 243. So 9 questions after this one. Question number 243. Question you might be familiar with, because when I was teaching you about torque and acceleration, I picked up this exact question to give you as an example. Nevertheless, because it's an Irodov question, so we'll just solve this question as given in the book. So you see, there is a diagram over here where this is the ceiling and a pulley is suspended. A light thread with a body of mass m is wound on a uniform solid cylinder of mass m and radius r. So this is your cylinder. Keep in mind, a cylinder is basically for us a disk. Okay. There are two aspects of this. As you solve more and more problems, you'll get a very good idea. For us, a cylinder is a disk. But even then, I'll not take the moment of inertia as half mr square. I'll write that the radius is r, the moment of inertia is I, and the mass is m. So that gives us some flexibility. Because in some cases, you might have problems where there is a sphere that is attached, or maybe there is a shell that is attached. So just one solution will be like, sufficient to deal with all those cases as well. So just keep it as I. Okay. The mass of the block is equal to m. So this mass over here is equal to m. The radius is equal to r. What is it asking us? Find out the angular velocity of the cylinder and the kinetic energy of the whole system as a function of time. So we haven't talked about kinetic energy. So we'll not talk about kinetic energy right now. It's basically asking us to find out the angular velocity as a function of time. Find out the angular velocity as a function of time. So how do you do that? How do you find out the angular velocity as a function of time? You might have probably already solved a question in Newton's law of motion where you find out the velocity as a function of time. Okay. So how do you do that? Alpha is known. You will find out alpha right now. So alpha is equal to d omega divided by dt. So this implies that d omega is equal to alpha dt. If you integrate on both sides, right now, if you integrate on both sides, why? Because we want to find out omega. To go from d omega to omega, you have to integrate. To go from omega to d omega, you have to differentiate. Correct? This knowledge is like already there with you. So if you integrate, you go from 0 to t. And for the angular velocity, you go from some initial angular velocity to some final angular velocity. Correct? So now what can you write on the left side? On the left side, you can write omega f minus omega I. So omega f minus omega I is equal to alpha is a constant. So you will just write t minus 0, which is just t. So this equation basically says that omega f is equal to omega I. Whatever initial velocity was there, that will still be there, plus whatever acceleration you are causing. So this is what this equation means in English. Basically, it is whatever initial velocity was there with you, plus whatever acceleration that you are causing, whatever angular acceleration, so to say, that you're causing. So if your angular acceleration is not there, the final velocity is going to be equal to your initial velocity. Okay, that's basically what it means in English. Our plan is कि from this equation, from the problem, we'll somehow find out the value of alpha. Okay. Read the question once. At moment t is equal to 0, the system is set in motion. So because the system is set in motion, the system was initially at rest. So omega I is equal to 0. Our answer is therefore just alpha into t. We will find out alpha, we'll multiply t, and that will be our answer. Okay, so let's start. How do you do it? First of all, you draw a free body diagram. You take your cylinder or sphere or whatever round body it is. This is your pivot. That's the axis, and that's the symbol for an axis also. What forces are going to act on this? There is a block. So on the block, you will have tension, and the same tension is going to act on the cylinder because of the string. The same exact tension is going to act on the cylinder. So that is T. Now on the block, you will have the weight mg. Weight obviously acts on the cylinder, but the pulley, the pivot is going to support that weight. So we don't need to talk about weight. After this, what kind of motion is going to happen? The block is going to fall down, say with an acceleration of a, and the pulley is going to rotate because the block is falling down with an acceleration of alpha. तो ब्लॉक जितना तेज नीचे गिरेगा, पुली उतना तेज घूमना चाहिए, क्योंकि ब्लॉक नीचे गिर रहा है तभी तो पुली घूम रहा है ना. तो अगर पुली घूमना बंद कर देगा, ब्लॉक नीचे गिरेगा कैसे? या अगर मान लो ब्लॉक नीचे नहीं गिर रहा है तो पुली क्यों घूमेगा? दोनों का मोशन जो है दैट इज लिंक टू ईच अदर, सो यू कैन से दैट ए इज इक्वल टू आर अल्फा। तो जितने रेट से ब्लॉक तुम्हारा नीचे गिर रहा है उतने रेट से तुम्हारा पुली यहाँ पे रोटेट कर रहा है। सो दैट इज द रिलेशन बिटवीन द लीनियर मोशन ऑफ द ब्लॉक एंड द रोटेशनल मोशन ऑफ द पुली, एंड दैट इज इक्वेशन 1। हमें यहाँ से अल्फा चाहिए, कीप दैट इन माइंड। Next, you write an equation for the block. So for the block, you can write plus mg minus t is equal to m into a. Second equation that we have. For the pulley, हम लोग क्या लिख सकते हैं? Plus r into t. Why plus r? Because the tension is causing the rotation. Same direction में देखो, think of a steering wheel. तो tension जिस direction में लग रहा है उस direction में घुमाओगे तो alpha भी उसी direction में. तो plus rt is equal to I into alpha, and that is equation number 3. समझ में आया? तो यहां से हम लोग क्या करेंगे, सबसे पहले t निकालेंगे, t इज इक्वल टू आई डिवाइडेड बाई आर, और हमें यहाँ पे अल्फा चाहिए तो वी विल जस्ट कीप अल्फा एज इट इज, और इस t को ले जाके हम लोग इक्वेशन नंबर 2 में डाल देंगे। सो व्हाट आई प्लान टू डू इज आई वांट टू टेक दिस t एंड पुट इट इन इक्वेशन नंबर 2। सो व्हाट आई विल गेट, mg माइनस आई अल्फा डिवाइडेड बाई आर इज इक्वल टू m इंटू a, और a का वैल्यू इज r अल्फा। ठीक है, अब इसको राइट साइड ले जाते हैं, तो एम जी इज इक्वल टू एम आर अल्फा प्लस आई अल्फा डिवाइडेड बाय आर। मेरे को अल्फा चाहिए तो मैं अल्फा के हिसाब से सॉल्व कर रहा हूँ, तो आई टेक अल्फा कॉमन विच लीव्स मी विथ एम इन टू आर प्लस आई डिवाइडेड बाय आर is equal to mg. So if this thing feels a little bit odd to you, you can also take r common. So alpha into r into m plus I divided by r square is equal to m into g. अब अल्फा का वैल्यू कितना आएगा, m into g divided by r divided by m plus I divided by r square. तुम इस चीज को और भी सिंप्लीफाई कर सकते हो। व्हाट कैन यू डू, यू कैन कैंसिल द m फ्रॉम द न्यूमरेटर, तो न्यूमरेटर से m चला जाएगा, डिनोमिनेटर से भी m चला जाएगा, तो यू विल बेसिकली गेट अ स्लाइटली डिफरेंट इक्वेशन ओवर हियर। यू विल गेट 1 प्लस i डिवाइडेड बाय mr स्क्वायर। तो ये अपना अल्फा है। What we wanted was the angular velocity as a function of time, which will be equal to g by r. Just remember that we have to multiply by t. So you multiply it with t and you leave it as it is, 1 plus I divided by mr square. Now coming to the problem that we have. In our problem, our cylinder, our body is a cylinder, it's a disc. So we can write I is equal to half mr square. हम लोग लिख सकते हैं I is equal to half mr square. और I divided by mr square is equal to 1 divided by 2. तो I by mr square का जो वैल्यू है यहाँ पे, we can remove I by mr square. ठीक है, तो खुद से पूछो, दिस इज इक्वल टू 1 डिवाइडेड बाई 2। हम लोग यहाँ पे लिख सकते हैं दिस इज इक्वल टू 1 बाई 2। सो विद दैट चेंज व्हाट इज द डिनोमिनेटर बिकम 3 बाई 2। तो अगर तुम इसको लिख दोगे तो ये हो जाएगा 2 बाई 3 g डिवाइडेड बाई r इंटू टी। सो दैट इज आवर एंगुलर वेलोसिटी एज अ फंक्शन ऑफ टाइम। है ना, आसान है, इट्स अ वेरी स्ट्रेट फॉरवर्ड कैलकुलेशन। I will not say that it's an obvious calculation, but the reason I keep saying that these things are kind of easy is simply because what? It's simply because you can write down the equations and you can straightforward solve it to an answer. Okay. Now keep one thing in mind. The mass of the cylinder and the mass of the block are not the same. So the answer that we got is an extremely simplified answer, and these equations are kind of wrong in that sense. So एक बार पीछे जाते हैं and let's slightly correct our equations so that we can match what is given in the question exactly. In the question, the mass of the disk is equal to capital M. It's not small m. So you cannot just cancel out all of those values. So this equation is exactly correct. इसके आगे हम लोग क्या करेंगे, अल्फा इज इक्वल टू एम जी डिवाइडेड बाई आर डिवाइडेड बाई एम प्लस आई बाई आर स्क्वायर। इसको हम लोग और चेंज नहीं कर सकते। सो वी कैन राइट अल्फा is equal to m into g divided by r, cannot change, divided by m plus, what is the moment of inertia of a disk? It is equal to half capital M r square. यहाँ पे जो moment of inertia of the disk आएगा, that is equal to half capital M r square. So if you divide that by r square, you will simply get capital M divided by 2. तो अगर तुम इस चीज को सॉल्व करोगे, सेम चीज को अगर तुम सॉल्व करोगे तो यू विल गेट ओमेगा इज इक्वल टू, ठीक है, ओमेगा इज इक्वल टू, सो आई विल आल्सो मल्टीप्लाई बाय t, multiply the entire thing by 2 also, so you will get 2m g divided by r multiplied by t, because we have to multiply by t, divided by, तुमने पूरे चीज को 2 से मल्टीप्लाई किया तो नीचे भी 2 से मल्टीप्लाई करोगे, m plus 2m. First of all, when I solved it at that point of time, I cancelled out the m to show you that sometimes you can cancel out the m. But in this case, the mass of the cylinder and the mass of the disk are different masses. Their values are not the same. So you cannot just go ahead and cancel it out like that. The values will be different. So this is the answer you get, which is equal to 2m into g by r into t divided by m plus 2. ठीक है, समझ में आए? तुम इसको चाहो तो और भी सिंप्लीफाई कर सकते हो, दैट्स अप टू यू. दैट्स 243. नाउ क्वेश्चन नंबर 244, the question right next to this one. The ends of thin threads tightly wound on the axis of radius r of a Maxwell disk. What the hell is a Maxwell disk? A Maxwell disk is a cylinder. So first of all, in this question it says Maxwell disk. So a Maxwell disk is a cylinder with threads on it. Okay, it's basically like a spool of thread that you're hanging. So imagine that there is a spool of thread, like, you know, there is some kind of a support that you can hold, and from this support a thread is tied and it is attached to a cylinder. So the cylinder can fall down. We have also done a very similar problem to this one. So let us say the mass of the cylinder is m, the moment of inertia of the cylinder is I, and the radius of the cylinder is r. So radius r of the disk is given here as small r. So I'll change my symbol over here. The radius is given as small r. When the disk unwinds, you are raising this bar. You are raising this bar so that the cylinder doesn't fall. The cylinder, it doesn't fall. Okay. The downward motion of the cylinder is prevented. The cylinder doesn't fall. So what does doesn't fall mean? It means that the downward acceleration is equal to 0. It means the downward acceleration of the cylinder is equal to 0. तो अब हमें बताना है कि find the tension of each thread. Find the tension of each thread and the acceleration of the bar. तो bar का acceleration क्या है and what is the tension in each thread? Let's solve this question one by one. First of all, because the cylinder is going to fall, you're going to prevent it by raising the bar, right? But because the entire thing is happening, the cylinder is certainly going to rotate. It will rotate. This will rotate. So if it is going to rotate, let us say the angular acceleration of the cylinder is equal to alpha. The cylinder is not going to fall down, but something is going to happen, right? The cylinder cannot float in the air. The cylinder is going to start rotating and you suddenly pull the bar up so that the cylinder cannot fall down, kind of like a yo-yo, okay? Not the yo-yo that you're thinking about, okay? It's a toy, go and search. Another point is, because there is a thread, so there is going to be tension in the thread. There is going to be angular acceleration alpha. There is also going to be mg. So you draw a free body diagram. In the free body diagram, you mark out all the forces. So tension is acting upwards, mg is acting downwards, and there is an angular acceleration alpha, but we know that this thing is not going to fall down. The linear acceleration is equal to 0. So because the linear acceleration is 0, if you write down the forces in the vertical direction plus mg minus t, then that should be equal to 0, because the block or the cylinder is not falling. जब कोई चीज गिर ही नहीं रहा है तो इसका एक्सेलरेशन कितना होना चाहिए? एक्सेलरेशन 0 होना चाहिए. तो t का वैल्यू कितना आएगा? t will be equal to mg. फर्स्ट इक्वेशन, t is equal to कैपिटल M into g. ठीक है, पहला चीज. अब दूसरा चीज, who is providing the tension? You are holding the thread with a support, so you are pulling the thread and you are providing the tension. So when this thing is accelerating, you can write plus r into t. See, think of a steering wheel. The tension direction is the same as alpha. So plus RT is equal to I into alpha. So from here you can write alpha is equal to R into T divided by I. Keep in mind this thing is a disk. So we can solve this problem right now and we can find out the value of alpha. So we can write R into T. So remember, the moment you put in the values, the answer becomes specific to this question. And what is the value of I? I is equal to mr squared by 2 because it's a disk. You cancel m, you cancel 1r and you flip the 2 up. So you'll get 2g divided by r. So the angular acceleration of this disk is equal to 2g divided by r. What does that mean? That means that the speed of the disk is increasing at 2g by r. What is connected to the disk? This thread. So the speed of the thread is also increasing at that same rate, 2g divided by r, except that the motion of this thread has acceleration. It has a linear acceleration. The cylinder is not moving, but as the cylinder rotates, the thread is going to start opening. So the thread is going to have an acceleration of a. We have already done this. A is equal to r alpha. So the thread has an acceleration of r into this, which is equal to 2g. So the acceleration of the thread is equal to 2g. What is connected to the thread? The bar that you're holding. So the acceleration of that bar has to be equal to 2g. So there are two answers to this question. The first answer is, what is the value of tension in the thread? So the value of tension in the thread, as we just found out, is equal to m into g. It is equal to the weight of the cylinder. And what is the acceleration of the thread? The acceleration of the thread is equal to 2 into g. Okay, it's equal to 2 into g. Samajh Maya, did you get it? Okay. Now the point over here is, if you notice in the figure, I have drawn two dots. That was to just kind of slightly simplify the question for you to understand. Actually, you cannot hang a disk with one thread. It's going to fall down. So to actually hang a disk, you need to pass a very thin rod, and you have to connect both ends of this rod to a thread. So that is the actual figure. And the disk is going to be on this rod like this. So the tension we have calculated is actually the total tension in both of these threads. So the tension in each thread is going to be half the value that we have calculated. That is mg by 2. बाकी सब कुछ ठीक है, but this is mg divided by 2. So that's it. The answer is equal to mg by 2 in each thread. Total tension is mg, but mg by 2 in each thread, so half in each thread, and the acceleration is equal to 2g. I have always suggested that you should find out the acceleration in the general terms r into t divided by I, and later on put the values. In fact, you can just put this value that t is equal to mg. So you can write alpha is equal to r into t. So instead of t, you can write mg divided by I, and therefore a is equal to mg r square divided by I. ऐसे करके तुम लिख सकते हो, ठीक है? So that's the solution to 244. Let's go ahead. Question number 253. First of all, how have I chosen these questions? I chose these questions keeping two things in mind. First of all, these are questions that we have already covered in, we have covered the concepts in class. And secondly, these questions leave out anything that we have not done. So like kinetic energy, angular momentum, I did not ask any questions based on that. Apart from these questions, there are some questions that you can also solve. So I would encourage you to actually go through all the questions on your own. And if you can solve something else, you'll feel very happy about it. Question number 253. A uniform cylinder of mass m 8 kg. See, in the figure of this question, you can see the two threads that I was talking about. Okay. So when we solve this question, we will draw only one thread. But keep in mind that one thread contains the total tension of both threads. Okay. Think about this. If you cannot imagine this, imagine that you're hanging from the ceiling with one hand. That's pretty hard. But if you try holding the ceiling with both hands, or if you try holding a rod with both hands, you can easily hang from it. Go and try. Okay. Hanging with one hand is slightly hard, but hanging with both hands is kind of very easy. That's because each hand is sharing the weight of your body. But when you hang with one hand is sharing the weight of your body, which you may not be strong enough to do. If you're strong, really nice. Okay. So there are two threads. Each thread is sharing the tension or the weight of the entire cylinder. हम लोग इसको draw कैसे करने वाले हैं? What we are going to do is we are going to draw the support, the ceiling as just one line. We are going to draw one single thread, and we are going to draw the entire cylinder under it. So this thread is equal to the two threads that the figure is actually showing. Okay, so if I draw the figure over here, so this is the figure that the book is showing. This is the figure. So there are two threads, and this is a cylinder that you have. So both the threads are just one thread. So this thread and that thread are together one of my threads. Anyway, ठीक है. So neglecting the mass of the thread, find the tension in each thread. So let the tension in each thread is T. So our value will be equal to 2T. and the angular acceleration of the cylinder. So it wants us to do two things in one part itself. So find the tension in each thread and the angular acceleration of the cylinder. Find the time dependence of the power. So you may not be able to solve for the power part, but I will still try to explain that to you. तुम कर सकते हो और टेंशन और acceleration तो हम लोग directly निकाल लेंगे. In fact, right now I would encourage you to pause the video and do this question yourself. तुम आराम से T और alpha निकाल लोगे अगर थोड़ा सा try करोगे तो. ठीक है, अब मैं try करता हूँ. So you have your cylinder. Let us say the mass of the cylinder is equal to m. The mass m is given, radius r is given. A cylinder is actually a disk, but I'll still take I. Keep in mind, your cylinder is always a disk. Okay, half mr square. It is a disk. So for all calculations, whenever you're given a disk or a sphere or a shell or anything, you take the moment of inertia as I, and in the last step, you can finally substitute and find out what the actual value is. तो अभी हम लोग I लेके इसको solve करते हैं. ठीक है, तो टेंशन लग रहा है ऊपर के डायरेक्शन में. सो टेंशन इज एक्टिंग इन द अपवर्ड डायरेक्शन. हाउ मच? 2t, one from each thread. What is acting in the downward direction? Weight. So mg is acting in the downward direction. What is going to happen? The entire thing is going to fall down. In addition to that, the entire thing is also going to rotate. So alpha आ जाएगा. So entire thing is going to fall down and also rotate. So rotation is alpha and falling down is a. तो हम लोग 2-3 बार इसको सॉल्व कर चुके हैं और अब तुम्हें ऑलरेडी पता है कि a is equal to r alpha, where a is the falling down part and alpha is the rotating part. ठीक है? If you have ever opened any kind of a roll, like you open a carpet or any kind of thing, or even a curtain that is rolled up, so the moment you open it, or even a blanket that is rolled up, the moment you open it, तो जितना तेज तुम उसको खींचोगे उतना तेज वो घूमेगा. Imagine this in your head. If you can't, then go and find a bowl of thread, wool या जो भी है, try to pull the thread. The entire thing is going to start spinning. जितना तेज खींचोगे वो उतना ही तेज घूमता है. ठीक है, अब इक्वेशन लिखते हैं. डाउनवर्ड डायरेक्शन में गिर रहा है. सो द फर्स्ट इक्वेशन वी विल राइट इज, लुक टू द लेफ्ट साइड ऑफ द स्क्रीन, प्लस mg minus 2t is equal to mass into acceleration. Now you will take the center of mass as the axis. Always I'm taking the center of mass as the axis. What will you write? For tension you will write plus r into 2t is equal to I into alpha. What do I want to find out? I want to find out t, and I also want to find out alpha. So what we'll do is we'll actually find out alpha and then we'll find out t using this equation. So you take the value of t from here. T is equal to I into alpha divided by 2r, and you put this value in the first equation. So you take this value and put it in the first equation. So you will get mg minus 2 into I alpha divided by 2r is equal to m into a. So instead of a, you will put r into alpha. You're used to doing this. So now solve. So you'll get mg is equal to I alpha divided by r plus mr into alpha. You can divide the entire equation by r, and you can also find out the value of alpha at the same time. So alpha is equal to, okay, I'm going to do a lot of things at the same time. You see if you can figure out. G by r, I divided the entire equation by r. I'm also dividing the entire equation by m. So I divided by mr square. Here there is only one mass, which is the mass of the cylinder. So I divided by mr square. So what is the angular acceleration? Angular acceleration is equal to g by r divided by 1 plus I divided by mr square. ये अल्फा का वैल्यू है. अब अगर अल्फा का वैल्यू पता चल गया तो t का वैल्यू कितना होगा? So t is equal to I alpha divided by 2r from the equation that we have. So t is equal to I alpha divided by 2r. ठीक है. So I by 2r साइड में रखो. What is the value of alpha? G divided by r into 1 plus I by mr square. So G by r square ये सब इधर आ जाएगा. तो what will you get? You will get Ig divided by 2r square divided by 1 plus I by mr square. That's the value of tension. That's the value of alpha. Now you can see that I is equal to half mr square. So wherever you have I by mr square, you can just directly substitute 1 by 2 over there. So this will become G by r divided by 1 plus 1 by 2. So 1 plus 1 by 2 is 3 by 2. So when it goes up, it is going to become 2 by 3, 2G by 3r. Same thing will happen over here also. So I is equal to half mr square. ठीक है, I is equal to half mr square. So 1 plus half is equal to 3 by 2. 3/2 का उल्टा is equal to 2/3 into I. Again I is equal to half mr square divided by 2r square multiplied by g. Slow it down, think about it once again. तो r square कटेगा, 2 के साथ कटेगा, फिर भी एक 2 बचेगा, so that will be equal to 2 into 3 6. So your answer will be equal to m into g divided by 6. So there are two answers to this question. Tension is equal to mg divided by 6 and the angular acceleration that I got is equal to 2g divided by 3. Okay. So if you find this question, struggled with this question and you could not solve it, or you were not so confident with solving it, just go back and try to draw the free body diagram once again. एक बार अच्छे से फ्री बॉडी डायग्राम को दोबारा ड्रॉ कर लो, एक बार देखो कि तुमने फ्री बॉडी डायग्राम सही से ड्रॉ किया है। तो अगर तुमने फ्री बॉडी डायग्राम सही से ड्रॉ किया है, इसके आगे तुम्हें क्या करना है, बस इक्वेशंस लिखने हैं। लीनियर मोशन का भी इक्वेशन लिखना है और फिर उसके बाद रोटेशनल मोशन का भी इक्वेशन लिखना है। A is equal to R alpha हम लोग यूजुअली लिखते हैं because whenever something is moving it is also rotating, at least in this chapter it's also rotating. So the linear motion and the rotational motion of that object are related to each other. तो उसके हिसाब से हम लोग लिखते हैं A is equal to R alpha. बात समझ में आया? ठीक है, so that is 253. We have 4 more questions to go. 258. The next question is question number 258. इसको try करते हैं. So 258 कहाँ है? The arrangement shown in figure 1.64 consists of two identical uniform solid cylinders, each of mass m, on which two light threads are wound around symmetrically. So to simplify the entire thing, what I'll do is, देखो कि यहाँ पे एक pivot लगा हुआ है. There is a rod connected over here. So because the rod is connected to the first cylinder cannot fall. This cylinder can't fall. It can't fall. It can only rotate. इसका बस रोटेशन हो सकता है. तो लेट अस से इट्स एंगुलर एक्सेलरेशन इज अल्फा 1. इसके साथ एक और सिलेंडर कनेक्टेड है which is just below that cylinder, so that cylinder is over here. This cylinder is free because when the thread opens it can fall, so let us say its acceleration is a2 and this thing can also rotate, so it will rotate in any direction it wants. I'll assume that it rotates in this direction, so its angular acceleration is going to be alpha 2. I did not use A1 because A1 is equal to 0. So basically you can write A1 is equal to 0. This is cylinder 1, that's cylinder 2. What are the different forces acting in this problem? There is tension and these cylinders are identical. So the mass of this cylinder is m, the mass of that cylinder is m. Its moment of inertia is I and the radius is r. So those cylinders are identical. It could also be two spheres. So we are just going to play safe and write I. अब तुम्हें क्या करना है? इस चीज का रिलेशन लिखना है. Keep in mind over here, there are two things that are rotating. There is the first cylinder that is rotating and there is also the second cylinder that is rotating. So you cannot write A is equal to R alpha simply because there are two different accelerations. Okay? तो अपने पास दो accelerations हैं, अपन directly नहीं लिख सकते. So what we will do is we will write what is called as a constraint relation. We will write a constraint relation. Actually A is equal to R alpha is also a constraint relation, लेकिन वो मैंने कभी बताया नहीं because I wanted to keep things simple for you to understand. तो अपन क्या बोलेंगे? We'll say that this point on the top cylinder P and this point on the bottom cylinder, they both move with the same acceleration. ठीक है? And because they both move with the same acceleration, this point over here that is falling down with an acceleration A2 is rotating with respect to Q. एक second. Let's do it one by one. What is the acceleration of P? The acceleration of P is equal to R alpha, as usual. R alpha 1. Because this thing is rotating, because the top cylinder is rotating, the point P is coming down. तो ये तुम्हें आसानी से समझ में आ जाएगा. फर्स्ट वाला जो सिलेंडर है वो रोटेट कर रहा है, इसलिए P वाला जो पॉइंट है वो नीचे जा रहा है. This means that acceleration of Q is equal to R alpha 1 because P and Q they move at the same rate. जितना P नीचे fall करेगा उतना ही Q नीचे fall करेगा. They both move at the same rate. तो ये Q का acceleration. How about the center of mass of the cylinder? The center of mass of the cylinder is falling as well as rotating. So the acceleration of the center of mass is because Q is falling down plus because the entire cylinder is rotating. Two contributions to the acceleration of center of mass. एक तो Q नीचे गिर रहा है इसलिए center of mass नीचे जा रहा है और ऊपर से cylinder rotate कर रहा है इसलिए center of mass नीचे जा रहा है. तो हम लोग यहाँ पे लिखेंगे Q का value which is equal to R alpha 1 प्लस रोटेशन ऑफ द सिलेंडर, तो हम लोग वहां पे लिखेंगे आर अल्फा 2. So A2 is equal to R alpha 1 plus R alpha 2. So there are two equations that we have. The first one is actually not important. We have already used it in the second one. So there are actually two equations. One for the first cylinder, which is rotating, and one for the second cylinder, which is also rotating. हमारे पास यहाँ पे दो equations. अब हम लोग क्या करेंगे? We'll write down the equation for the forces. तो इसको करने के लिए you first of all draw a free body diagram. So I'll go and draw the first cylinder, the second cylinder separately, and then you draw all the forces that are acting. तो इस पे टेंशन T नीचे की तरफ लग रहा है, इस पे टेंशन T ऊपर की तरफ लग रहा है, और इसका जो वेट है इसका वेट लग रहा है नीचे की तरफ. So that is mg. Keep in mind this is A2. The value of A1 over here is equal to 0, so we do not need to write an equation for this. However, this cylinder is rotating, so this one is alpha 1, and this cylinder is also rotating. I just drew the direction wrong. This cylinder is rotating, this is alpha 2. तो ये सारे rotations अपने cylinders में हो रहे हैं. So there is alpha 1, the first cylinder is rotating, the second one is rotating at alpha 2, and the second one is also falling with an acceleration which is equal to A2. अब इसके equations लिखते हैं. तो इसका सबसे पहला इक्वेशन क्या लिखोगे? प्लस एम जी. वी आर राइटिंग इट फॉर द सेकेंड सिलेंडर, फॉर सिलेंडर 2. ठीक है, सिलेंडर 2 मतलब तुम्हारा नीचे वाला सिलेंडर, दिस वन. प्लस एम जी माइनस टी इज इक्वल टू एम इंटू ए टू. ठीक है, फटाफट लिखते हैं. फिर उसके बाद टेंशन के लिए क्या लिखोगे? टेक द सेंटर ऑफ मास एज द एक्सिस ऑफ रोटेशन. सेफेस्ट मोस्ट करेक्ट थिंग टू डू. So what will you write? Plus R into T is equal to I into alpha 2. That's the second equation. अब पहले वाले equation पे जाते हैं, पहले वाले cylinder पे जाते हैं. Can the cylinder move? No. The only thing the cylinder can do is it can rotate. So you will write plus R into T is equal to I into alpha 1. समझ में आया? Plus R into T is equal to I into alpha 1. अब इस पूरे चीज से हमें निकालना क्या है? Find the tension in each thread in the process of motion. So the question is asking us to find out the tension in each thread. हमें यहाँ से कैसे भी करके tension निकालना है. So we will reframe our answers in such a way that end में अपने पास tension आ जाए. तो सबसे पहले अपन क्या करेंगे? We will write down the value of A2. तो A2 is equal to mg minus t divided by m. यहां से हम लोग अल्फा 2 का वैल्यू लिखते हैं. तो अल्फा 2 इज इक्वल टू आर टी डिवाइडेड बाई आई. यहां से अल्फा 2 लिखते हैं और वहां से अल्फा 1 का वैल्यू लिखते हैं. तो अल्फा 1 इज ऑल्सो इक्वल टू आर टी डिवाइडेड बाई आई. एटलीस्ट इट लुक्स लाइक दैट. ठीक है, तो ये अल्फा 2 का वैल्यू है, वो अल्फा 1 का वैल्यू है, और वो A2 का वैल्यू है. But what is A2? A2 is equal to R alpha 1 plus R alpha 2. So let us take this equation and let's put all the values that we got into this. So you'll get mg divided by n minus t divided by n. So this is the value of what? A2. ये A2 का वैल्यू जो अपन ने डिराइव किया. फिर उसके बाद राइट साइड पे क्या आएगा? R into alpha 1. So what is alpha 1? RT by I. So it will become R square T divided by I, and again you will get R square T divided by I. हमें यहाँ से T निकालना है. तो G is equal to T divided by M plus T into R square by I. दो बार हो गया तो 2T R square by I. अब T को कॉमन ले जाओ तो T is equal to G divided by 1 by M plus 2 R square divided by. ठीक है, बात समझ में आया? So this is how you basically solve the problem. इसको थोड़ा सा और सिंप्लीफाई करना है तो कर सकते हो. बाकी क्या दिया हुआ है? There are two identical solid cylinders. So cylinder is like half m r square. So if it is half m r square, 2r square divided by m r square divided by 2. So that will become how much? 4 divided by m. So it is G divided by 1 by m plus 4 by m, which is equal to 5 by m. So the tension will be equal to mg divided by 5. So what is the tension in each cylinder? The tension in each cylinder is equal to mg divided by 5. ठीक है, तो अपन ने जो वैल्यू यहाँ पे निकाला है दैट इज फॉर बोथ द थ्रेड्स. ये चीज ध्यान में रखो कि अपन ने जो आंसर निकाला है यहाँ पे दिस इज फॉर टू थ्रेड्स. सो इफ यू वांट टू फाइंड आउट द टेंशन इन अ सिंगुलर थ्रेड दैट इज हाफ ऑफ दिस मच. सो द टेंशन इन वन थ्रेड इज इक्वल टू mg by 10. तो अपना जो T आया दैट इज द टेंशन फॉर बोथ द थ्रेड्स पुट टुगेदर, बिकॉज दैट इज हाउ वी सिंप्लीफाइड द क्वेश्चन. वी डिड नॉट ड्रॉ टू थ्रेड्स, वी ड्रॉ वन थ्रेड. तो अगर तुम्हें दो थ्रेड्स के साथ शुरू से ही ड्रॉ करना है तो T की जगह पे 2T लिख के सॉल्व करना, सीधे आंसर mg by 10 आएगा. वरना तुम टी लिख के सॉल्व करोगे तो ध्यान रखना तुमने दोनों थ्रेड्स को एक थ्रेड मान के चला है, तो फिर एंड में जब जाओगे तो टी को t/2 तुम्हें करना है। समझ में आया? फंडा सिंपल है, लाइक यू नो समथिंग इज रोटेटिंग, समथिंग इज मूविंग, तो रोटेशन का इक्वेशन लिखो, मोशन का इक्वेशन लिखो, दोनों को रिलेट कर दो। रिलेट समटाइम्स मे नॉट बी वेरी स्ट्रेट फॉरवर्ड, so whenever a relation between linear and rotational motion is not straightforward, we have to do some kind of calculation like I've shown over here. Okay, so doing this is called as deriving a constraint relation. This requires a little bit of practice and experience, so you can do it. बाकी आई ट्राई टू एक्सप्लेन हाउ आई डिड इट ओवर हियर। मैंने बस सिंपल चीज़ बोला कि अगर Q नीचे गिरने वाला है, so I'll also draw it in a color you can understand. So if Q is going to fall, this point is going to fall. In addition to that, if it is going to rotate, so this point is going to fall even more because of the rotation. So both of those things are going to get added up and you're going to write this equation over here. One part is because of the rotation and the other part over there is because of falling. So those are the arrows you can figure out and you can solve it. समझ में आया? तो अपन ने अब तक कितने क्वेश्चन सॉल्व किए? वी हैव सॉल्व्ड अराउंड 5 क्वेश्चंस. लेट्स सॉल्व अराउंड 1 or 2 more questions before we wind up for today. तो इसके बाद का क्वेश्चन नंबर 259 है. Just the next question. In the arrangement shown in figure 1.65, a weight possesses a mass m and a pulley possesses a mass capital M. तो दोनों का सब कुछ पता है, कैपिटल M पता है, स्मॉल m पता है, सब पता है. So also known are the moment of inertia of the cylinder and everything is known to us. बस हमें क्या निकालना है? Find the acceleration of the weight after the system is set free. तो प्रॉब्लम क्या है? प्रॉब्लम ये है कि देयर इज अ सिलेंडर बट द सिलेंडर हैज टू डिफरेंट रेडाई टू इट. वो ज़्यादा समझ में आएगा जैसे बुक में ड्रॉन है, बट आई विल ड्रॉ इट इन अ वे दैट इज ईजी फॉर अस टू सॉल्व. सो दिस इज हाउ द सिलेंडर लुक्स लाइक फ्रॉम द साइड and the mass is hanging from this part of the cylinder. So this is your mass m and that is the cylinder of mass m, moment of inertia I, and radius is r and also 2r. So unevenly shaped cylinder. ठीक है, तो इसका हम लोग मान लेते हैं the moment of inertia is I. तो वहाँ पे लिखा भी हुआ है कि the moment of inertia is I and it has two different radii, it is R and 2. So even then understand that this is the center of mass of the cylinder. In this case the cylinder is going to rotate and there is only one angular acceleration of the cylinder. क्योंकि सिलेंडर जब घूम रहा है तो सिलेंडर का घूमना एक ही होगा ना, उसका रेडियस अलग अलग है तो दैट्स अ डिफरेंट स्टोरी. लेकिन जो घूम रहा है सिलेंडर, जैसे फैन घूमता है तो फैन का बीच वाला पार्ट जितना घूमता है उसके ब्लेड्स भी उतने ही घूमते हैं. ठीक है, तो उसका जो एंगुलर एक्सेलरेशन है उसका एंगुलर एक्सेलरेशन तो वही है. बाकी इसका जो सेंटर ऑफ मास है, इट इज गोइंग टू फॉल विद एन एक्सेलरेशन ऑफ a1 and this mass is going to fall with an acceleration of a2. So there are two accelerations, एक तो सिलेंडर का एक्सेलरेशन है और दूसरा मास का एक्सेलरेशन है which is equal to a2. Is the mass rotating? No. अब हमें इन सारी चीजों को रिलेट करना है. We have to do what is called as a constraint relation. So once again you are seeing a constraint relation over here. So यहाँ पे constraint क्या है? तो constraint यहाँ पे ये है कि ये जो पॉइंट है सेंटर ऑफ मास, ये जो पॉइंट है, ये जो पॉइंट है और ये जो पॉइंट है, जो चार पॉइंट्स हैं, देयर मोशंस आर लिंक्ड. ऑल ऑफ दीज मोशंस आर लिंक्ड विद ईच अदर. दिस पॉइंट इज नॉट गोइंग टू मूव. दैट पॉइंट इज एट रेस्ट बिकॉज इट इज टाइड टू अ थ्रेड. So basically because of the rotation of the cylinder, the center of mass is going to fall. Because the center of mass is going to fall, that point is also going to fall, and because that point is going to fall, this mass is also going to fall. So those are all the purple arrows. Second, this point is also going to fall because the cylinder is rotating. So that is going to add to the acceleration of that point. Now between these two points over here, there is no additional change. तो जितना ये ऊपर वाला पॉइंट गिरेगा उतना ये नीचे वाला पॉइंट भी गिरेगा. करके लिखते हैं. सबसे पहला रिलेशन ये है कि A1 is falling because of the purple arrow, because of the rotation of the cylinder. So that is simply R into alpha. This point over here at the edge is going to fall with the same acceleration as this point, which is A2. So A2 is equal to center of mass का जितना भी acceleration है, which is equal to A1, that is the purple arrow, plus pink arrow, which represents the rotational motion of the cylinder, so that is 2R into alpha. So what is the value of A1? R alpha plus 2R into alpha, so that is basically 3R into alpha, and that is the value of A2. तो अपने पास यहाँ पे दो equations हैं. A1 is equal to R alpha एंड A2 इज इक्वल टू 3R इंटू अल्फा। ठीक है, दो इक्वेशंस हैं। अब हम लोग इक्वेशंस लिखते हैं फॉर लीनियर मोशन। तो व्हाट इज द टेंशन इन दिस थ्रेड? लेट अस से इट इज इक्वल टू T1. What is the tension in this thread? Not the same. Let us say it is equal to T2. What is the mass of that cylinder? M. तो इस पे डाउनवर्ड डायरेक्शन में वेट लगेगा, that is equal to mg. What is the mass of this block? Small m, that is equal to small mg. So जो तुम्हारा सिलेंडर है तो that is equal to T. यहाँ पे ये T1 आ जाएगा, डाउनवर्ड डायरेक्शन में यहाँ पे आ जाएगा T2 और इस पे डाउनवर्ड डायरेक्शन में वेट आ जाएगा एंड द वेट इज इक्वल टू mg. यहाँ पे इस छोटे से ब्लॉक पे ऊपर के डायरेक्शन में रहेगा T2 और नीचे के डायरेक्शन में रहेगा इसका वेट विच इज इक्वल टू mg. Mark the accelerations out clearly so that you can write the equations without any thought. So this is equal to A2, that is equal to A1, and this is rotating with an angular acceleration of alpha. This radius is equal to r and the bigger radius is equal to 2r. Center of mass को हम लोग access बनाएंगे. At this point, if you have reached this point, the only thing remaining to solve the problem is to write the equations and to solve the equations. सब लोग ठीक ठाक हो, है ना? हमने बहुत सारे क्वेश्चन सॉल्व किए. नीचे द क्वेश्चंस आर काइंड ऑफ कॉम्प्लिकेटेड. सो इज एवरीवन ओके? ठीक है, सॉल्व करते हैं. सो नाउ व्हाट यू डू इज you write down the forces. So you will write plus mg, you will write plus T2, you will write minus T1 is equal to mass into the acceleration of the cylinder which is equal to alpha. So m into alpha आएगा, नहीं सॉरी m into a आएगा. सबसे बड़ा स्ट्रेस तो मेरे पे पड़ रहा है m into a1. ठीक है, that's your first equation. Next one, for the lower block you will write plus mg minus T2 is equal to m into a2. तो वो फर्स्ट इक्वेशन है, ये तुम्हारा सेकंड इक्वेशन है. फिर वहां पे क्या आएगा? एंगुलर एक्सेलरेशन. तो एंगुलर एक्सेलरेशन कितना आ जाएगा? T1 एंड T2 आर बोथ हेल्पिंग, सो यू विल राइट प्लस r इंटू T1 प्लस 2r इंटू T2, क्योंकि T2 के लिए इट्स 2r एंड दिस वन इज r. सो प्लस r इंटू T1 प्लस 2r इंटू T2 इज इक्वल टू I इंटू अल्फा. I इंटू अल्फा. ठीक है. What is the question asking? What is the acceleration of the weight? तो हमें basically A2 निकालना है. Keep the focus clear. हमें A2 निकालना है. बाकी सारी चीज़ों को हम लोग क्या कर सकते हैं? We can eliminate everything else. So whenever you're solving a problem, keep your focus very clear so that you can understand what to do and what not to do, and it will guide you in solving the problem. Now, what I see over here is that it will be kind of hard to solve directly for A1 and A2. So let's what can we do? We can we find out alpha over here? Even alpha is going to be difficult. If we find out alpha, alpha is also going to be difficult. तो अपन ऐसा करते हैं, अपन सब कुछ को A2 के टर्म्स में लिखने का कोशिश करते हैं. ठीक है, तो alpha is equal to A1 divided by R. I am thinking along with you. ठीक है, I haven't thought about this question before, तो मैं अभी तुम्हारे साथ सोच रहा हूँ. And I'm thinking of the best possible way to solve this. Okay, let's try this one. T1 plus 2 times T2 is equal to I alpha divided by R. ठीक है, पहला वाला इक्वेशन अगर हम लोग लिखेंगे तो T2 minus T1 is equal to MA1. तो M into A1 minus mg. Let's see. ठीक है, let's not be like absolutely perfect, लेकिन अपन थोड़ा बहुत ऑप्टिमाइज तो करते हैं. तो T1 और T1 यहाँ पे कैंसिल हो जाएगा, तो you will get 3T2 is equal to I alpha divided by R plus MA1 minus mg. ठीक है, अपन यहाँ तक पहुँच गए. Now A2 is equal to 3R alpha and A1 is equal to R alpha. So it looks like A1 is equal to A2 by 3. So let's make that switch. So A1 is equal to A2 divided by 3. How about alpha? Alpha is equal to A2 by 3R. So instead of alpha, जहाँ पे भी alpha है, तो we can just write A2 divided by 3R. So it will become IA2 divided by 3R square. अब फाइनली बचा T2 का वैल्यू. तो T2 का वैल्यू हम लोग इधर से ले सकते हैं, फ्रॉम द इक्वेशन जस्ट टू द लेफ्ट साइड, दिस वन. तो यहाँ से हम लोग A2 का वैल्यू लेते हैं. तो A2 इज इक्वल टू G माइनस T2 डिवाइडेड बाई M, G माइनस T2 डिवाइडेड बाई M, तो ये हो जाएगा E2 का वैल्यू. But by doing this, we kind of spoiled it. One second. Let's. We had 3T2. तो T2 के जगह पर हम लोग क्या लिख रहे हैं? T2 इज इक्वल टू एम जी माइनस एम ए टू. तो T2 के जगह पर हम लोग लिख रहे हैं एम जी माइनस एम ए टू. तो 3 टाइम्स T2 के जगह पर हम लोग यहाँ से लिखेंगे एम जी माइनस एम ए टू. कुछ तो भी गड़बड़ लग रहा था क्योंकि मैंने यहाँ पे ए लिखा है, T2 का वैल्यू चाहिए था. ठीक है, तो 3 टाइम्स एम जी माइनस एम ए टू. नाउ वी आर ऑल सेट. हमें बस M2 का E2 का वैल्यू चाहिए. तो इस इक्वेशन को फटाफट राइट साइड पे जाके लिखते हैं. 3mg minus 3ma2. Keep struggling through a question, okay? Never give up. So ia2 divided by 3r square. So ia2 divided by 3r square or ma2 by 3 minus mg plus ma2 divided by 3 minus mg. कर लिया mg plus 3mg इक्वल टू, सब कुछ राइट साइड पे लिखो लेकिन ए2 को कॉमन लेंगे. तो ए2 को कॉमन लेंगे तो पहले m/3 आएगा, प्लस ये जो 3m अपन लेके जा रहे हैं वो 3m आएगा, और फिर i डिवाइडेड बाई 3r² भी साथ में आता है. 3 वाला टर्म कहाँ से आ रहा है? 3 वाला टर्म आ रहा है r और 2r के सम से, तो वहाँ से आ रहा है 3. और बाकी ये सब इक्वेशन कैसे सही लग रहा है? बिकॉज ऑल द मासेस शुड एड अप. इधर अगर कहीं पे माइनस साइन आया मतलब तुमने कहीं तो गड़बड़ किया, और इस साइड पे तो ठीक है. वी कैन जस्ट राइट डाउन एंड फाइंड आउट एट द एंड आंसर क्या आता है. तो g को कॉमन ले जाओ. योर आंसर इज m प्लस 3m divided by m/3 plus 3m plus I divided by 3r square. So that's the answer that we have. You can go and check कि इसका आंसर क्या दिया हुआ है. It's such a long question. It's been so stressful for all of us कि अपन एक बार जाके चेक कर लेते हैं कि क्या आंसर है इसका. और अपन को क्या करना है? क्वेश्चन नंबर 259. 3g इंटू एम प्लस 3m. 3g इंटू एम प्लस 3m. थोड़ा बहुत इसको रीराइट कर देते हैं, 3 से पूरा मल्टीप्लाई कर देते हैं, तो 3g इंटू एम प्लस 3m, और नीचे इसको 3 से मल्टीप्लाई करेंगे तो m आएगा, फिर 9m आएगा, और फिर आएगा i डिवाइडेड बाई आर स्क्वायर, जो अपना आंसर है. सो